Hi there, and welcome to this lesson on Pure Mathematics 4. And in this lesson, we're on Chapter 7, 7.10, and the intersection points of lines in three-dimensional space. In two-dimensional space, there are only two possibilities for a pair of lines which are not collinear. They're not exactly the same line. Either those lines are parallel to each other, and they do not intersect, and you'll have something like that, or the lines are not parallel, and they do intersect at a single point, and you'd have something like that. In three-dimensional space, we have both of those two possibilities, and we have a third possibility. So either the lines are parallel and they do not intersect, or the lines intersect at a single point, or a third possibility. The lines are not parallel, but they do not intersect. Such lines are called skew lines, and they'd look a little bit like this. It's a bit like having the flight paths of two aeroplanes, where there was never any danger that the two planes would crash into each other, because the one flight path was above the other or below the other. Okay, let's have a look at an example. Show the lines L1 and L2 intersect and find their point of intersection. Now, a bit like in the previous lessons, I'll be creating a single column vector to get the equation of each line, and then you'll get equations for the I values, J values, and K values. I'll let you have a go at working your way through this yourself first. So see if you can make sense of what's going on, pause the video, come back to me when you're ready. Okay, let's have a look. So creating a single vector for the first line, I'd get that. Creating a single vector for the second line, I would get that. And then as before, we look at the I, J, and K values separately. So first of all, looking at the I values, 3 plus 2m must equal 1 plus n. At the J values, minus 2 plus m equals 12 minus 2n. Looking at the K values, 4 minus m equals 8 minus m. Now I've got a set of three simultaneous equations, but only two unknowns. So I need to choose one pair first of all to find m and n. I'm going to choose A and C, because if I add A and C together, the n's will cancel, and that'll give me 7 plus m is 9, and m equals 2. And then using equation C, that would give me 4 minus 2 is equal to 8 minus n, which means n is equal to 6. Now I need to check that these values work in equation B as well. And if I put m equals 2 and n equals 6 into equation B, this is what I would get, and I'd get 0 equals 0, which is true. So yes, the values do work in all three equations. To find the point of intersection of these lines, I can either substitute m equals 2 into the first line, which is what I've done here. And if I substitute m equals 2 in, multiply the brackets, add things together, I get 702 for the point of intersection. But equally well, I could substitute n equals 6 into the second line. And if I substitute n equals 6 into the second line, then I'd get this. But again, if I multiply the brackets, add things together, I get exactly the same answer. So 702, that's the point of intersection of these two lines. Example 2 asks us to show that these two lines are parallel to each other, but that they're not collinear. They're not just the same line. To show they're parallel, I'll need to consider the direction. To show they're not collinear, I'll need to consider a point on the line. Okay, I'll let you have a go at doing this yourself first. So pause the video, have a go, and then come back to me when you're ready. Okay, let's have a look. So first of all, I need to show the lines are parallel. That means I need to look at the two directions. So the direction of the second line is equal to a multiple of the first line. That means the lines are parallel to each other. To show they're not collinear, I need to find a point on one of the lines and show that it's not on the other line. Now, there are many ways to do that. I'm going to choose m equals 1 for the first line, and that would give me this, which simplifies to 5 minus 1, 3. So if m equals 1, the point 5 minus 1, 3 is on the first line. Now I need to show that that point is not on the second line. So checking if 5 minus 1, 3 is on the second line, that's the equation for the second line, written as a single vector. And I want to know if there's some value of n, which will give me that point for the answer. Looking at the I values, I'd get n equals minus 2 over 5. Looking at the j values, I immediately get a different value for n equals 13 over 5. So no, there isn't a value of n that would give me that point for the answer. Therefore, 5 minus 1, 3 does not lie on the second line. So I've shown that the two lines are parallel, but they are not collinear. And example 3, show that the lines L1 and L2 are skew lines. Now, to prove that they're skew lines, I need to show that they're not parallel to each other. I also need to show that they do not intersect each other. So first of all, I'll need to consider the direction of the lines, and then I'll need to consider what the intersection point would be if they did intersect. Okay, I'll let you have a go at that. It's very similar to the method we've used for the first two examples. Pause the video, come back to me when you're ready. Okay, let's have a look. So first of all, we need to consider the direction of the two lines. And what we're asking is if the direction of the second line, 1, 5, 3, is some multiple of the direction of the first line. That gives me three equations for m. Looking at the I values, I get m equals 1/2. Looking at the j values, I get m equals 5. Looking at the k values, I get m equals -3. So no, the one vector is not a multiple of the other. That means the two directions are not parallel to each other. So I've shown they're not parallel, these two lines. Now I need to show that the lines do not intersect. And I use the normal method for that. So writing down the equation of the first line as a single column vector would be that. The equation of the second line as a single column vector would be that. And again, I'll get three equations in I, j, and k. The first one is that for the I values. The second one is that for the j values. The third one is that for the k values. And again, I've got three equations in two unknowns. I need to choose two of them to find m and n. I'm going to use b and c. If I add b to c, then these m's will cancel with each other. And that'll give me 2 equals 20 plus 8n, which gives me a value of n of -9 over 4. If I substitute that back into equation c, then I'll get 4 minus m equals 8 minus 27 over 4. And that simplifies to give me m is equal to 11 over 4. So I've worked out values of m and n from equations b and c. If those work in equation a, then yes, the lines do intersect. If those do not work in equation a, then no, the lines do not intersect. So substituting those values into a, I get 3 plus 2 times 11 over 4. And the question is, does that equal 1 minus 9 over 4? Well, the left-hand side simplifies to 17 over 2. The right-hand side simplifies to minus 5 over 4. And no, 17 over 2 does not equal minus 5 over 4. So that means that there are no solutions for m and n that will make all three of these equations work. Therefore, the lines do not intersect. Because they're also not parallel, which we've already shown, that means they must be skew lines. Okay, that gets us to the end of this lesson. If you've got the textbook, turn to page 132 and have a go at exercise 7J. Thanks very much for listening, and cheerio.